These are the video notes for section 6.3, factoring harder trinomials. Before we get to the steps, I want to explain what a harder trinomial is. It's a trinomial with a number other than 1 in front of the variable squared. So 2x squared plus 7x plus 5 would be considered a harder trinomial because we have a number here that's in front of the x squared that's other than 1. So the steps that we have is order trinomial if necessary, then factor out GCF if possible, multiply the first and last number, write factor pairs including variable, create math expression to get entire middle term, replace middle term with math expression, and factor by grouping. So in our first example, we're going to skip the first two steps because it doesn't apply, and we're going to multiply the first and the last number, which is 2 and 5. 2 times 5 is 10. Now we're going to write the factor pairs including the variable this time. So we have 1x and 10x, and 2x and 5x. In our previous lesson, we did not include the variables because we were dealing with basic trinomials. Now our next step says create math expression to get the entire middle term. The entire middle term is a positive 7x. Of these two factor pairs, the top one does not get us that. 2x and 5x is the only one that would get us a positive 7x. Now we're going to complete the math expression with positive and positive. Step 6, replace the middle term with the math expression. So our middle term was positive 7x. Now we're going to replace it with plus 2x plus 5x plus 5. Now we're going to do the last step, which is factor by grouping. We're going to group the first two and the last two terms, factor out the GCF, 2x, x plus 1 is left. Factor out the GCF, which is positive 5. We have x plus 1 is left. Then we're going to factor out the GCF, which is x plus 1. And then we have 2x plus 5 that is left. In this example, we're going to skip the first two steps. So we're going to multiply 3 times 2 to get 6. So we have 1x and 6x, 2x and 3x. If you notice, both factor pairs actually gets us a positive 5x with a negative and positive here, positive and positive here. What we have to do is we have to complete the problem but do it twice because we have two possibilities. So let's take a look at the first one. If we use the first one, we'll get 3x squared minus 1x plus 6x plus 2. I'm going to factor by grouping. The GCF is x here, 3x minus 1. The GCF here is 2, so you get 3x plus 1. If you notice, there is no GCF between this entire term, so we know now that this is not the correct possibility to use. So we're going to use this one, and we'll get 3x squared plus 2x plus 3x plus 2. Factor by grouping. The GCF is x. I'm left with 3x plus 2. The GCF is 1. I'm left with 3x plus 2. So you can see right away the difference between this and this. Here you're going to end up with a GCF of 3x plus 2, so we can continue to factor, and then we're left with x plus 1. In this example, we're going to order the trinomial. And we're going to also factor out the GCF, which is negative 2. Just like when we had a GCF with a basic trinomial, we're going to leave the negative 2 and put it in our final answer, followed by the 2 parentheses. So I'm going to multiply the 12 and 1 to get 12. The factor pairs is 1x and 12x, 2x and 6x, and 3x and 4x. The only factor pair that would get us a negative 1x would be the last one. This would be plus minus to get us a negative 1x. So now I'm going to replace the term here, the middle term, with our math expression. And then we're going to continue to factor by grouping. Now when I factor by grouping, you're going to end up with parentheses, but there's already a parentheses here because of the GCF. So what we're going to do is we're going to put brackets now, so that when I factor out the GCF, it won't look too confusing. So the GCF is 3x, and you're left with 4x plus 1. The GCF is negative 1, you're left with 4x plus 1. Now I'm going to factor this part, the GCF, which is 4x plus 1, and then I have 3x minus 1 left. And then don't forget about the GCF that's in front, we have a negative 2 as the GCF. In our last example, we need to put this in order, so we're going to write 2t squared minus 6t minus 19. We're going to multiply 2 and 19 to get us a 38. The factor pairs of 38 is 1t, 38t, 2t, and 19t. We're trying to get a negative 6t. If you notice our factor pairs, neither one will get us a negative 6t. So what we write here is prime or unfactorable. In our last example, 2x squared plus 7xy plus 5y squared, if you notice, it's very similar to the first example that we did in the beginning of the video. The only difference, if you notice, is that we have the extra variable y, and we have a y squared at the end and a y in the middle. The answer to this problem is actually x plus y . Now you're going to start over. In our last example, 2x squared plus 7xy plus 5y squared, if you recall, our first example looked like this. These two problems are very similar, but there's only the difference of a variable y that is tacked on at the end as y squared and a y in the middle. If you look at the final answer that we have here, it's very similar to the final answer that we have here. The only difference is we include the variable y at the end of each parentheses. So if you see a problem like this where you see two variables, what you could do is you can ignore the variables at the end, rewrite it, factor it as you normally would, and then when you get your answer, you include the variable at the very end.